So we're going to talk about how to simplify some of these expressions, and there's a couple things that we're going to learn how to do. The big one, though, is multiply and divide. So multiplying these radicals is really, really easy if the index is the same, meaning they are both square roots or they are both cubed roots or what have you. So the square root of 3 times the square root of 15, if you had to guess what the answer to that problem is, what would your guess be? Square root of 15 is the correct answer.
He gave the answer. It's like
You just multiply the two together. It's that easy. So if I were to give you one that's like, here's some variables, what'd you say the answer was? It's square root of 21x. That is exactly right. Easy. Huh? It's like the square root isn't there. So doesn't have to be square roots.
But as long as they're the same root, you can put them together.
As long as they have the same index, that is exactly right. So the fourth root of 125 times the fourth root of 5. What is 125 times 5? It is 625. Very good. Now that one makes me suspicious because I think it might be possible to simplify the fourth root of 625. So I'm going to try it. I'm going to go ahead and bust out the calculator and do the fourth root of 625. So do 625, press the y square root of x button, and then press 4 because it's the fourth root. And it does come out very nicely. So I'm going to write 5 for my answer because 5 is the simplified answer.
So we should simplify.
You should simplify it if you can. These 15 and 21 cannot be simplified, so I don't have to worry about those. 625 made me suspicious. It was so giant that we could simplify it, so we tried. This one's pretty great. Don't get mixed up that there's two different variables, x's and y's. Do the numbers first. 5 times 3.
15.
And then we've got an x squared, and then we've got a y, just like that. Oops. That seems all right. I don't think I can take the cubed root of 15, so we're going to call it good right there. And that's it. That's all there is to it. That doesn't seem bad at all. Doesn't seem bad at all. Let's do division. Division's also not too bad. Division is going to require a little bit more work from you, but not a lot. We've touched on this a little bit. When you take the square root of a fraction, it looks just like this. Fractions are division. Do you remember what you do here in this scenario?
Square root each one.
Yeah, square root each one. That's exactly right. Not bad. Square root of 25 is... And square root of 49 is, how about that? Same deal with the variables. That is going to be the square root of x over the square root of 9. Now the square root of x I can't simplify because x isn't a number. So I'm just going to leave that as the square root of x. But on the bottom, square root of 9 is, there we go. That seems pretty good. Works with cube.
The rational symbol stays up there.
Yeah, it stays up there because I don't know what the square root of x is. Like, it could be anything. So I'm just going to leave it like this. All right. How about this one? The cube root of 8 over cube root of 27. Cube root of 8 you should be familiar with by now. Cube root of 8 is 2. Cube root of 27 probably a little less familiar to you. You may need a calculator for that, but it's 3. That doesn't seem bad. Let's do a fourth root one just to really ruin your life. Okay. So this is going to be the fourth root of 5 on top, and it will be the fourth root of 81x to the 8th on the bottom. The fourth root of 5 cannot be simplified, but the fourth root of 81x to the 8th can be. What's the fourth root of 81?
9.
That's the square
no.
root. Fourth root is
3.
3. And the fourth root of x to the 8th is?
2.
X squared. Yeah, good. Good. So the quotient rule is also pretty easy. However, all the ones that I gave you just now, the square root, third root, fourth root, if you could take the root of them, they worked out perfectly. What if they don't work out perfectly? For example, something we've talked about earlier is how I can get an answer to this question by putting the square root of 50 into the calculator. And the disadvantage of doing that is if I put the square root of 50 into the calculator, I end up with a decimal that I have to round. What if I need the exact answer? I do not want to round it. I want the exact answer. Okay, so here's what you do. This is a square root. So what I want to do is I want to divide the number 50 into a product of two different numbers. For example, something like 5 times 10 would be a product of two numbers that equals 50. But I don't want just any two numbers that equal 50. I want two numbers that equal 50, and I want one of those numbers to be a perfect square. So what are two numbers I can multiply by 50, and one of them's a perfect square? 25 times 2. So I'm going to rewrite this as the square root of 25 times 2. 25 is the largest perfect square that 50 can be divided by. Now here's what I've gained with this. I can split this apart into the square root of 25 times the square root of 2. What is the square root of 25? And the square root of 2 I will just leave as the square root of 2. And this is the exact answer, meaning an unrounded answer. 5 times the square root of 2. That is the exact answer.
My calculator will give me that answer.
It may. Some calculators will and some won't. So I wanted the biggest perfect square that 50 could be divided by. Okay, let's try another one. Square root of 98. So I want to divide 98 into the product of two different factors. But I want one of the factors to be a perfect square. What is the largest perfect square that 98 can be divided by? 49. So I'm going to rewrite this as the square root of 49 times 2. I can separate that into the square root of 49 times the square root of 2. The square root of 49 is 7 times the square root of 2. And that is the exact answer. Unrounded, the pure, raw, uncut math. That's the good stuff, straight from the source. Works with cubed roots too. Okay, I want to take 54 this time, and I still want to split it into the product of two factors, but this time I want one of the factors to be a perfect cube. So like 1 cubed is 1, so 1 would be a perfect cube. 2 cubed is 8, so 8 would be a perfect cube. 3 cubed is 27, so 27 would be a perfect cube. 4 cubed is 81, so 81 would be a perfect cube. I know it's not 81 though, because that's bigger than 54. So what's the biggest number I just said that 54 can be divided by?
27.
27. 54 is the equivalent of the cubed root of 27 times 2. 27 times 2 is 54. Okay, so let's break it apart. The cubed root of 27 times the cubed root of 2. And we know the cubed root of 27 comes out nicely. That's why we picked it. What is the cubed root of 27? 3 times the cubed root of 2. Okay, let me give you a goofy one. That's a square root again. So I want to know what is the largest square root, or the largest perfect square, that 35 can be divided by. Perfect squares would be like 1, 4, 9, 16, 25, 36. I know it's not 36 because that's bigger than 35. So the ones I said that were lower than 35 were 1, 4, 9, 16, and 25. Which one of those can 35 be divided by? What's 35 divided by 25?
What were our choices?
Any perfect square. 1, 4, 9, 16, 25. What's the biggest one 35 can be divided by?
And it not give you.
No decimals.
No decimals,
Right.
no fractions?
Right. 1. 1's the biggest one it can be divided by. So the simplification of this is the square root of 35. That is as simple as it gets. Okay? What is the biggest perfect fourth that 35 can be divided by? Now when it starts to get like these, you may want to start making a list. 1 to the fourth is 1. 2 to the fourth is 16. 3 to the fourth is 81. I know 81 won't work because it's bigger than 32, so it's got to be 1 or 16. What can 32 be divided by? 16 is the biggest. So this would be the fourth root of 16 times 2, which would be the fourth root of 16 times the fourth root of 2. And the fourth root of 16 is 2. So this is 2 times the fourth root of 2. Hot dog. Okay? Square root of 25x cubed. So here's where these start to get a little weird, because I can take the square root of 25. Square root of 25 works out perfectly. I can't take the square root of x cubed. So I'm going to separate these. And I feel pretty good about the first one. The square root of 25 is just 5. The square root of x cubed doesn't come out nicely. So I'm going to come down, I'm going to put this one over here. It's 5. I'm going to do some more work on this one. The square root of x cubed. What is the biggest perfect square that x cubed can be divided by? Now variables are really easy because perfect squares for variables have to be variables with even numbers. So x squared, x to the fourth, x to the sixth, x to the eighth, these are all perfect squares for variables. So when I start listing those, x squared, x to the fourth, x to the sixth, x to the eighth, what's the biggest one of these that x cubed can be divided by? X squared is the biggest one it can be divided by, right? So I'm going to rewrite this as the square root of x squared times x, just like I've done on the other ones. Perfect square times whatever's left over. X squared times x is x cubed. So this is the square root of x squared times the square root of x.
That one's just X.
This one's just x. And this one's just going to be the square root of x. And that is going to go over here. And there's my answer. These are tricky. These are tricky. Okay? Just mentally prepare yourself. These are tricky. Now, sometimes you'll get just god-awful, nasty problems like this one that have so much going on, it's hard to know even really where to start, okay? And when that happens, it's totally fine to split these up into 3 separate problems. What I mean by that is, let's break this apart into the cube root of 54, the cube root of x to the 6th, and the cube root of y to the 8th, and just multiply these things all together. Let's break them down one piece at a time. That'll be a little easier for us. Now, one of these things is really, really easy. Of these 3 that I just wrote, which one was the easiest? Yeah, the middle one, because what's the cube root of x to the 6th? That's x squared. 6 divided by 3 is 2. Easy. This one's not too bad. What's the largest perfect cube that 54 can be divided by? Well, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. I know it can't be 4 cubed because that's bigger than the actual number. So 1, 8, 27, what's the biggest one of those 54 can be divided by? 27. So I'm going to write this as the cubed root of 27 times 2. 27 times 2 is 54. So that'll be the cubed root of 27 times the cubed root of 2. And the cubed root of 27 is 3. Okay. So I have successfully found the cubed root of 54 and the cubed root of x squared. So the one that's left to me is the cubed root of y to the 8th. Just like the square root variables had to have even exponents, multiples of 2, the cubed root ones have to be multiples of 3. So examples of, just down here. The examples of perfect cubes variable-wise would be like y cubed, y to the 6th, y to the 9th, y to the 12th. What's the biggest one of those y to the 8th can be divided by? I know it can't be these, they're too big. So y to the 6th. So this is the cubed root of y to the 6th times what? Y squared. There we go. Yep, what's the cubed root of y to the 6th? Y squared times the cubed root of y squared. Okay, success there as well. So individually, I have found the cubed root of all 3 of these things, but now I got to put it back together. Anything that is not inside of the cubed root symbol needs to stay outside of the cubed root symbol, and anything that's inside goes inside. What I mean by that is, when I look at all 3 pieces here, what stuff is not inside the cubed root? Well, the 3 is not. The x squared is not. And the y squared is not. Then I'll do my cubed root. What is inside the cubed root? That too. and that y squared. And this is the answer. All right. Let's do a quotient rule problem. So one of the ways that we did the square root of a fraction was we split it apart, do the square root of the numerator, then do the square root of the denominator. You can go the other way. If I'm already doing the square root of the numerator and the square root of the denominator, let's back up. Let's do the square root of 20 divided by 5. Now, why in the world would I want to do that? Well, because 20 divided by 5 is what?
4.
That's 4. So this problem is, what's the square root of 4? It's just 2. That's why I would do that, because look how easy that is. It's much easier to put them back together. It's also easier to put them back together when you get something like this. Now, the stuff that is both inside the square root can be put back together. So what I mean by that is I could do a big square root, but the 98z and the 2 can go inside of it. The 3 can't. The 3 wasn't inside the square root, so I can't put it there with the square root. So what happens to the 3? It stays outside, but I need to make sure that I remember the 3 was in the denominator, not in the numerator. So when I write it out in front, I'm going to write it as this fraction, 1/3, so that I remember, oh yeah, 3 was in the denominator. The square root of 98z over 2, I can just put that together, right? What's 98 divided by 2? That's right, 49. So this is the square root of 49z. I can separate this into two different things. 1/3 times the square root of 49 times the square root of z. That's an advantage for me because the square root of 49 is just some number. The square root of z, I'm afraid, is going to have to stay inside the square root. So this is 1/3 times, what's the square root of 49? 7 times the square root of z. And then I can just multiply these together. 1/3 times 7 is 7/3 square root z. I like this answer. Also would be totally acceptable to put this as your answer. Those are equivalent and I like them both. Okay, I want to finish up by sharing two formulas with you. We're going to do one example of each and then we'll be done for now. Here are the two formulas I want to share with you. The first formula we're going to learn is the worst. It's called the distance formula. The distance formula is used to tell how far apart two coordinates are. So if I gave you coordinates like, here's an x and a y coordinate, we'll call them x1 and y1. And here's another set of coordinates, x2 and y2. If I said how far apart are those two coordinates on the graph, the distance formula is the formula you would use to answer that question. Okay, so here's what the distance formula looks like. It's a big square root, and what you do is you find the differences between the x's and square it, plus you find the differences between the y's and square it. It's actually based on the Pythagorean theorem. The square root of a squared plus b squared maybe at a later date when everybody's not about to fall asleep, I will show you where this formula comes from. But it's from the Pythagorean theorem. Your textbook, I believe, has a proof of it where it comes from in the Pythagorean theorem, which is fairly interesting if you're curious or if you have insomnia. So in order to do this problem, all you need to know is 2 points. So I'm just going to make up a couple of points here. And the question will be something like, what's the distance between these 2 points? So all you're doing is plugging these points into the equation. Now the equation's got 2 x's and 2 y's, so really the only challenging part here is which ones are the x's, which ones are the y's, and then which one's x1 and which one's x2. Now the x has got to be the first number and the y has got to be the second number. So -3 is going to be an x and 7 is going to be a y. And -2 is going to be an x and 3 is going to be a y because the x always comes first. Now which one is x1 and y1 and which one is x2 and y2 doesn't matter as long as the 1's are in the same ordered pair and the 2's are in the same ordered pair. So I'm going to call this one x1 and y1 just because I wrote that first. And this one's going to be x2 and y2 because we wrote that one second. But to be clear, I'm only labeling them that way because that's the order I wrote them in. If you switched these, x2, y2, and x1, y1, you would get the same answer. So don't get too hung up on that. So here we go, distance formula. Let's plug in our numbers. So the first part's x2 minus x1. So my x2 is -2 minus the x1, which is -3, and it's squared. Notice I've got minus a negative because it was minus -3. Plus y2 minus y1 squared. I got a little bit of arithmetic to do here. What is -2 minus -3? Well, that's the same thing as -2 plus 3, which is 1, and 1 squared is 1, plus 3 minus 7 is, and -4 squared is +16. So when it's all said and done, this is the square root of 17. The square root of 17 is the exact answer because I did not round anything. Now, square root of 17 is great if you need really precise calculations, like if you're landing the rover on Mars or something, square root of 17 is great. But if you said, how far away is this thing, and I said it's square root of 17 miles, you would punch me in the face, and rightfully so. Square root of 17, I have no idea how big that is. So if you were asked for the approximate answer, you could do the square root of 17 on your calculator, 4.1231.
Couldn't you also simplify 16?
I can't because it's 16 plus 1, not 16 times 1. Not exact, derp. This is the approximate answer. And that's from the calculator. You will be asked for both. What is the exact answer? What is the approximate answer? And you got to know those. The second and final formula, final thing we will learn in class this evening, is called the midpoint formula. Now the midpoint formula does not use square roots. In fact, this formula is quite a bit simpler than the distance formula. The reason you're learning it is because the midpoint and distance formula go together a lot. The midpoint formula, you also get 2 coordinates. But the question is not how long are they. The question is what coordinate is exactly in the middle. Here it is. You add the 2 x's and divide by 2. Then you add the 2 y's and divide by 2. Just like the distance formula, you've got 2 coordinates, and just like the distance formula, you label them x1, y1, and x2, y2. But the math here is much easier, and there's no square root, so bonus. Let's say these were the 2 coordinates I gave you. And I asked for the midpoint. Just like with the distance formula, I do need to label them as the x's and y's. So x has to be the first number and y has to be the second. And I'm going to label the 5, -2 as x1 and y1 for no better reason than I wrote that one first. So that would make 8, -6, the x2, y2. Then we're going to plug these into the formula, but the formula is really easy. It'll be x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. And now it's nothing but arithmetic. 5 plus 8 is 13, so this is 13 halves. And -2 plus -6 is -8, so this is -8 halves. 13 halves is fine like it is. I can divide it and get a decimal, but it's fine as is. But 8 halves can reduce. What can it reduce to? -4. And I don't need to worry about exact answer versus approximate answer because it's fractions and whole numbers. Those are both exact and, I guess, approximate because you can't do any better than those. That's as accurate as you can get. You could put 6.5 if you felt like it instead of 13 halves, but same thing. Whew! Does anybody have any questions about one of the 97 things that we talked about this evening? Or did you all nail it and you know it perfectly and you're going to make 100 on everything from here on out?